And so we look at reflection again. Here's an object, the light from it falls on the surface and is reflected. Your eye, seeing the ray coming from this direction, assumes it's coming in a straight line and sees the image right there. And so, again, important to see that we've evolved to see things travel in straight lines. And that's how we think things are coming. So, here, the light from here would reflect here and go back there. He would make a straight line. It would look like it was coming from here. Okay, and so that's stuff on water. You could see that the reflection off of water depends on how smooth the surface is. And so you've kind of seen when it's not very smooth, you have a pattern that looks like this. But if it gets really, really calm, then you might see a dot kind of like that over there. Okay, very calm water back there. Here we see refraction. See how the light bends towards the normal. Here's a normal is a hypothetical line there. So when it goes from a less dense medium to a more dense medium, it bends towards the normal, and when it comes out, it bends away from the normal, giving us these illusions of the spoon being bent in water or the bottom of a pool being not as deep as it is. And so here we look at um, your convex lens, and this basically is doing the same thing, is bending it towards the normal and then away from the normal, and the curvature increases the bend. And so now we have a point where all the light focuses onto. This is like a magnifying glass, or kind of like my glasses that I use to see things up close. And so we call this a converging lens because it's bringing the light to one point, converging it. And this is called a diverging lens, which does the opposite, bending it away from the normal and making it spread away. These are the kind of glasses, when your light is falling over here, it's converging too much. So you want to diverge it a little bit before so that it falls right where you want it to fall, which is your retina over there. For people who are farsighted, and that's kind of like me, my vision, instead of falling, my focus, instead of being on this retina here, happens in the back. So when I use a lens like this, it helps converge it a little bit ahead of time so that my eyes can do the rest. And that, again, a survival trick. If you're ever trying to harpoon fish, if you see the fish over here, where you're looking at it, it's actually not there. It's lower than it is. So always aim a foot or so lower if you want to not go hungry. Okay. And so there's this PowerPoint that you can go over, take some notes. We kind of went over most of it right here. Then we have a second PowerPoint, which is basically looking at light again from a more of an electromagnetic wave point of view. And then I'd like you to kind of play around with this convex lens simulator. Again, this is the converging lens we looked at earlier. And see, when I place the image far away, the lines come in a straight line. They bend towards what's called the focal point, and that's where all the light is converging to. Now, if I bring it up closer, and I bring it somewhere up here, you see that I have an image that is smaller and upside down, and I haven't reached twice the focal length yet. 2f is twice the focal length. When I come to twice the focal length, I get the image to be exactly the same size as the object, but it's upside down. And then I keep moving up closer. When I come between 2f and f, my image has gotten larger than it was before. And we can see as I keep coming in at f, the image completely disappears because the rays of light are going parallel. They never meet. And then I come in even closer and something funny happens. The image is now on the other side. It's a virtual image, meaning I can't put it on a screen, but I can see it with my eye. And so I want you guys to finish working through this, and then you have a